Hello. All right. So my name is Jason Gefeller, and I am your science teacher this year. We're going to be doing some video lectures. The reason we do video lectures is A, they don't take a bunch of class time for me to just talk at you because that's no fun. B, you can slow down, pause, stop, rewind, all those fun things to take notes. And C, you can look at them whenever you want over and over again. You can look at the beginning of chapter, see all the things. You can look at them at the end of the chapter to review. So hopefully they'll work out and they'll be helpful. All right. So I guess we'll just jump right in. What is science? Well, this first chapter is all about science, scientific method, and what biology is in particular. So, there we go. Science can be looked at two ways. First off, it's an organized way of using evidence to learn about the natural world. So it's a process. It's something we do. We do science, the verb. It can also be, though, a noun, a body of knowledge we've built upon those years of doing the scientific process, of doing science. Okay, so a lot of times in class, we look at science as that body of knowledge. I got to know this, 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 and this. But really, we're going to try and get out that science is the way we can learn about the natural world. The goals of science are to investigate and understand the natural world. We try and explain events in nature and use those events to make predictions. Like explain how this antelope lives, what it eats, where does it live, how many live in a herd, what that herd structure is like, and then from those explanations we can make predictions. If something happens to one of its diet staples, what's going to happen to the herd? If something happens to an area of land that the herd migrates to, what's going to happen to the gazelles? Did I say antelope? That's a gazelle. I'm sorry. Hopefully I said gazelle. Whatever. By the way, the editing software I use doesn't let me edit, so we're going to leave any little mess ups in there. Feel free to laugh. Hey, features of science. Key things about science that make it slightly different than other disciplines. A, it deals with the natural world. Okay? Anything you can see, feel, touch, smell with your senses or with an addition to your senses like a microscope or a telescope. It collects data and organizes information to look for patterns. So humans have an awesome mind that looks for patterns in everything, and science just tries to extrapolate on those patterns. And they try to propose explanations from those patterns that can be tested by examining new evidence. So if you're not proposing explanations, not trying to explain things and figure out what's going to happen, it's not really science. It's just a fact. So your observations are kind of the basis of all of science. It's where it all begins. Without observations, there would be no science. An observation uses one of the five senses. We gather all those observations in what we call data. So data is just written down observations. One of the fun things I've heard is the difference between messing around and doing science is recording data. So it's a lot of fun. You just got to actually know what you get out of it. The reason I put this telescope here is, again, observations use your senses, but we can use tools to heighten our senses. Okay? So just because I can't see an atom with my naked eye doesn't mean that doesn't exist. I can use other tools to sense and figure out that atoms are there. There's two different types of observations. Quantitative, think quantity. Quantities have to do with numbers, so quantitative observations have to do with numbers. And qualitative is description. So is the thing slimy? Is it yellow? Is it large? Those are qualitative observations. From these observations, we want to interpret the evidence. Data means nothing. I'm wearing a red shirt. Nice. That's a fact. I want to understand why it's red. Why does the light that it absorbs versus the light that it reflects makes my eye see the color red? Right? Part of interpreting evidence is using inferences, and inferences are logical interpretations based on prior knowledge and experience. So that data and what we already know, we can put together to explain what's happening. Okay? So from all the data, we try and pull out the information that's relevant and create knowledge based around that. It's kind of the flow of science. We don't just stop at the data, we have to understand the data. To help further explain that data, though, sometimes we create hypotheses. These are possible explanations. Okay? Lots of times we don't know exactly what's going to happen. In science, we don't know every answer. And so we've got to come up with a hypothesis to try and figure that out. Hypotheses in science are only useful if they're testable. So if I come up with some off-the-wall hypothesis, like there's a leprechaun that's invisible in my fridge, that when I open the door, he flips on the light switch, can't really test that. Okay? So your hypotheses have to be testable. And to test them, lots of times we use experiments. But a lot of people think experiments are only good if they come out correct. But that's a misunderstanding. Experiments can support your hypothesis. That's cool. Tells you you're right. They can disprove your hypothesis. That's also cool because it tells us what's not right. And knowing what's not right gets us closer to knowing what's right. And they can partially support your hypothesis. So say they support some parts but not the other. That's also cool. We can keep the good parts and tweak the rest to make a hypothesis that works and then retest that. Okay? Scientific view is kind of the way science looks at the world around us. Okay? And a couple assumptions we have. One main one is the universe operates off of rules. Okay? Think of physics, all the rules of physics, all of those dwindled down into chemistry and biology, so it's all governed by rules. And these rules, we assume the human mind can understand. And those are two big assumptions. There's rules, and we can understand those rules. Okay? So science is that ongoing process to try and understand those rules. And when we find something wrong in science, we revise it. We fix it. Okay? We keep an open mind, but we're skeptical. So it's those two things kind of hard to balance. I've got to be open to new ideas if there's evidence to support them, but I've got to be skeptical of those new ideas until there's evidence to support them. Okay? It's kind of being willing to accept things, but having to be shown why you should accept those things. And that's kind of how science looks at the world. But why even study science? What's the point of studying science? Well, science can lead us to knowledge about the world. Knowledge about the world is good, understanding what's going on. That knowledge can lead to understanding why things work, how things work. That understanding can lead to values, what we should, I don't want to use the word value, what we should care about and protect, okay, how we should act. And those values can lead to actions. Okay? So, example, hybrid car. Science, invented the car, invented the internal combustion engine, modes of transportation, gave us knowledge of how that worked, how fossil fuels are burned, led to an understanding of how when we burn those fossil fuels, we release carbon dioxide into the atmosphere, what that's doing to the planet with climate change and all those fun things. Could lead to values about caring about the planet, could lead to actions like buying a more fuel-efficient car. All right. That's science. The scientific method, on the other hand, is one way to do science. So right now, I am about 8 minutes into this video. So that's probably a good stopping point. We'll come back in the next video and talk about the scientific method. By the way, for future reference, the software I use also stops recording at 10 minutes. So none of these videos can ever be longer than that. All right, I got a little long-winded. I wanted to go farther, but that's okay. We'll stop now. Thanks for watching.